Okay, good morning to everyone. In the previous video, we discussed about the syllabus of introduction or syllabus and introduction to kinetics of machinery. Now, kinetics link also we have discussed. What is meant by kinematic link and what are the types of links? That is rigid link, flexible link, fluid link, and then we have discussed about kinematic pair also. In that kinematic pair, we are mentioned that constrained motion. So the two elements are joined, which is having relative motion, okay, or constrained motion. Then the two elements combined you are calling as pair, and these two elements having relative motion, then it is called as kinematic pair. Now in this video we are going to discuss about kinematic pair classification and types of constrained motions. So now first we will discuss about types of constrained motion, then we will discuss about the classification of kinematic pairs, then mobility or kinematic chain, and kinematic, is it a kinematic chain or can check it. So that we will discuss in this video. Now types of constrained motions. In this, generally three types of constrained motions are having. So first one, completely constrained motion. When the motion between a pair is limited to a definite direction, motion is limited to a pair. Okay, motion of between a pair, any two elements called as pair. So in that pair, the motion is limited to a definite direction irrespective of direction of the force applied. Whatever may be the direction of applied force, but the motion is limited to only one direction, then the motion is called as completely constrained motion. Completely constrained motion. Example for this is piston and cylinder in a steam engine or reciprocating IC engine, okay, form a pair, and the motion of the piston is limited to a definite direction relative to the cylinder irrespective of the direction of motion to the crank. Whatever the crank motion, but the piston will be reciprocates, therefore it is called as completely constrained motion. Now another example is square bar in a square hole, motion of a shaft with collars with at each end in a circular hole are also examples of completely constrained motion. Now these figures you can observe. So now this is the reciprocating steam engine mechanism. In this mechanism we are observing piston rod and guides. Okay, these are all comes under the cat one link, and connecting rod, small end bearing, big end bearing forms one kinematic link, and crankshaft and flywheel forms one kinematic link. Cylinder and engine frame is the another link. So such that these are four pairs are forming kinematic pairs. So in that we are observing constrained motion only for piston and cylinder. In between the piston and cylinder only constrained motion, because it is moving only one direction. Okay, it will not move for other direction. Whatever the applied direction portion of or crank motion, whatever may be the crank motion, the piston only reciprocates. That's why it is called as completely constrained motion. Next one is square bar in a square hole. So this is another example, square bar in a square hole. Square bar is moving only in a square hole by sliding motion, it not move any other motion. So that is why it is also completely constrained motion. Next other one is circular shaft with a end collars. So it is also rotates and it will not be slide. So that's why whatever may be the applied of direction of force. So that's why it is also completely constrained motion. Next coming to the incompletely constrained motion. When the motion between a pair can take place in more than one direction. So motion may be taking place more than one direction, then the motion is said to be incompletely constrained motion. Incompletely constrained motion, the direction is of impressed force may alter the direction of relative motion between the pair. Whatever the direction of applied force, that will be changes the direction of motion of the element. So that's why it is called as incompletely constrained motion. Example is circular bar or shaft in a circular hole, as it may either rotate or slide in a hole. These both motions have no relationship other. So that's why it is called as incompletely constrained motion. Circular shaft without collars in a circular hole is the example for incompletely constrained motion, because it may slide whenever moving in the direction of applied force, whenever it may cause to rotate also whenever the direction of force is changes. So that is applied force direction is changing, motion direction is also changing, then that is called as incompletely constrained motion. Next one is successfully constrained motion. So successfully constrained nothing but with forming a pair is such that constrained motion is not completed by itself. Motion of completely is not by itself but by some other means, then the motion is said to be successfully constrained motion, or it is also called as partially constrained motion. Successfully or partially constrained motion. Example is footstep bearing. The shaft may rotate in a bearing or it may move upwards when we are not applied any force on the shaft. That is called as incompletely constrained motion. But if the load is applied on the axial moment, to prevent the axial moment of the shaft, then the motion of the pair is said to be successfully constrained motion. Similar to that, motion of an IC engine valve also, and the piston reciprocates inside the engine and cylinder are also examples of successfully constrained motion. Okay, IC engines or valves are moving because of spring force only. So that's why we are to prevent the motion of the other directions, the spring or something, by means of some other means we are restricting the motion in other direction, then it is called as successfully or partially constrained motion. The example you can observe, this is the footstep bearing. When the load is applied, it will be acting without motion to the upwards, it will only rotate. That's why it is called as successfully or partially constrained motion of the footstep bearing motion. Okay, shaft motion, shaft in a footstep bearing. Next one is classification of kinematic pairs. So now kinematic pair. So before going to the classification of kinematic pair, already in previous video we have defined the kinematic pair. So first, what is pair? Two elements are joined, then it's called as a pair. So these two elements which are having relative motion to one another, then that is said to be kinematic pair. So that relative motion should be constrained motion. So generally then completely or successfully constrained motion, then it is called as a kinematic pair. Now the classification of kinematic pairs based on different criteria we can classify. The first one is based on the relative motion between the elements. Okay, according to the type of relative motion between the elements. So first one is sliding pair. So when the two elements of a pair are connected in such a way that one can only slide relative to the other, the pair is known as sliding pair. So that is relative to one element slides over the other. So like this. So it is moving, sliding like this. One element slides over the other, then the pair is known as sliding pair. So example for this is square bar in a square hole and piston and cylinder, crosshead and guides of a reciprocating steam engine, ram and its guides in shaper, tailstock in on lathe bed are the some of the examples of sliding pair. Some of the examples you can take. So piston, cylinder, okay, piston reciprocates inside the cylinder, so including crosshead and guides of a reciprocating steam engine. Now ram and its guides also, ram is moving on guides in shaper, tailstock is also moving on lathe bed. So these are the examples, some of the examples of sliding pair. So sliding pairs are completely constrained motion. So this having completely constrained motion. Sliding pairs has completely constrained motion. Next, coming to the second one, turning pair. When the two elements of a pair are connected in such a way that one can only turn or revolve about a fixed axis of another link, the pair is known as turning pair. So whenever one is revolving or like this, turn or revolve about another link, then the pair is known as turning or turning pair or revolving pair. So now when one element revolves or turns about another link, then that is called as a turning pair. So a shaft with collars at both ends fitted into a circular hole. Shaft with collars. So is the example for this. Okay, the crankshaft in a journal bearing in an engine, lathe spindle supported in headstock, cycle wheels turning over their axles are the examples of a turning pair. So wheels are rotating about the axle. So that is one of the example. Or journal bearing in crankshaft in journal bearing also is one of the example. And shaft with collars ends fitted with the circular hole also another example of turning pair. Turning pair also has a completely constrained motion. Next, coming to the rolling pair. When two elements of a pair are connected in such a way that one rolls over another link, another fixed link, the pair is known as rolling pair. So now one element is rolling like this, so rolls over the another fixed link, then the pair is known as rolling pair. So example is ball and roller bearings are examples of a rolling pair. Okay, rolling pair examples, ball and roller bearing. Next, coming to the screw pair. When two elements of pair are connected, two elements of a pair are connected in such a way that so one element can turn about other by means of screw threads. By means of screw thread, one is turning, then it is called as a that pair is called as screw pair. Example is bolt with a nut, lathe bed, lead screw with a nut, lathe lead screw with a nut are the some of the examples of a screw pair. Next one is spherical pair. So when two elements of a pair are connected in such a way that one element, so which is in the form of spherical shape, turns or swivels out about the other fixed element. So one element is in the form of shape, spherical shape, swivels or turns about the other fixed element. The pair formed is called as spherical pair. Example for this is ball and socket joint, attachment of a car mirror, pen stand are the some of the examples of a spherical pair. So even you are observing most of the cases car mirror will be spherical movement is there. Okay, that is why it's called a spherical pair. Pen stand is also one of the example. Ball and socket joint is also another example of spherical pair. Next, classification of kinematic pairs according to the type of contact between the elements. Lower pair. When two elements of a pair have surface contact, when relative motion takes place and the surface of one element slides over the surface of the other, the pair formed is known as lower pair. So two elements which are having surface contact and they are having relative motion or slide one element slides over the other, then it is called as a lower pair, surface contact. So sliding pair, turning pair and screw pair forms the lower pair. These are the example for the lower pairs. Any sliding pair, turning pair and screw pairs can be taken as a lower pair. When two elements of pair have line or point contact, then the relative motion takes place and the motion between the two elements is partly turning or partly sliding, then the pair is known as higher pair. Okay, higher pair means so then two elements are having line or point contact. When relative motion takes place, then the relative motion between the two elements is also partly turning and partly sliding, then the pair is known as higher pair. Examples is a pair of friction discs, toothed gearing, belt and rope drives, ball and roller bearings, and cam and follower are the some of the examples of a higher pairs. This is another classification of kinematic pair. Next classification of kinematic pair is according to the type of closure. So self-closed pair and force-closed pair are there. So first one is self-closed pair. When the two elements of a pair are connected together mechanically, two elements are connected mechanically in such a way that only required kind of relative motion occurs, it is then known as self-closed pair. Okay, the relative motion is occur in such a way that mechanically connected, then the pair is called as self-closed pair. The lower pairs are self-closed pairs. The lower pairs are self-closed pairs. Now force-closed pair. So when two elements of a pair are not connected mechanically but are kept in contact by the action of external forces. So two elements are not connected mechanically but they are keeping in contact by the action of external forces, the pair is said to be a force closed pair. So now in this case example is cam and follower mechanism is the one of the closed pair, force closed pair, and as it in contact by the forces exerted by spring and gravity. So that's why these are called as force closed pairs. Next one is kinematic chain. Okay, till now we have discussed about the types of constrained motions and types of kinematic pairs or classification of kinematic pairs based on the different criteria. Now we will discuss about what is kinematic chain. Okay, when the kinematic pairs are coupled in such a way that first link is joined to the last link. last link and first link are joined, then it is also having completely or successfully constrained motion, then it is called as a kinematic chain. Okay, first link and last link is joined and these are having completely or partially constrained motion, then that is called as kinematic chain. A kinematic chain may be defined as a combination of kinematic pairs joined in such a way that each link forms a part of two pairs. Each link forms a part of two pairs and the relative motion between the links or elements is completely or successfully constrained. Example is crankshaft of an engine forms a kinematic pair with the bearings which are fixed in a pair. Okay, crankshaft kinematic chain you can observe. So total reciprocating engine mechanism. Crankshaft of an engine forms a kinematic pair with the bearings which are fixed in a pair. Now the connecting rod with the crank forms a second kinematic pair. The piston with the connecting rod forms third pair and the piston with the cylinder forms a fourth pair. So these are the total four pairs are connected. First and last pairs are joined. Then it is called as a kinematic chain. Now the total combination of these links is called as a kinematic chain. Now if each link is assumed to form two pairs with two adjacent links, then the relation between the number of pairs forming a kinematic chain and number of links may be expressed in the form of an equation. Okay, L and P. Number of pairs and number of links is known. L is equal to 2p minus 4 is the equation. So this is the relation. Then this equation is satisfied, it is a kinematic chain. Otherwise, it is not a kinematic chain. Okay, L equal to 2p minus 4, constrained kinematic chain. Now we are observing another forms part of two pairs. Therefore, there will be as many links as the number of pairs. Okay. Now another relation between the number of links and number of joints which constitute a kinematic chain is given by the expression J is equal to 3 by 2L minus 2. This is another expression. Okay. The above equations are applicable only to kinematic chains in which lower pairs are used. So these equations are satisfied with only lower pairs. So these equations may also apply to kinematic chains when which higher pairs are used. Then the higher pairs is equivalent to two lower pairs. Higher pair may be taken as equivalent to two lower pairs with an additional element or link. Then we can take as the you can substitute the equations. Next, apply the above equation to the different cases and is it a kinematic chain or not, you can check it. So first one is three links AB, BC and CA with pin joints at A, B and C. Now the figure will be seen in the next slide. Okay, a number of links is 3, number of joints is 3, number of pairs is also 3. Okay, kinematic pairs is 3. Okay, then equation you are substituting L equal to 2p minus 4. So number of links 3, then 2 into number of pairs 3 minus 4, substituting 3 equal to 2. The equation is not satisfied, therefore it is not a kinematic chain. Okay, next another way you can observe another equation also J equal to 3 by 2 L minus 2. So J is 3 and 3 by 2 into L is 3 minus 2, that we are substituting. So 3 is 2.5, got it. So it is not equal. So therefore it is not satisfied the equation. So it is not a kinematic chain. So this is the AB link, BC link, CA link. Three links are there. Three links are connected as a pin joints at A, B, C. Then it is not a kinematic chain. Left hand side value is more than the right hand side value. Then it is not a kinematic chain. So therefore it is called as a frame or structure. Okay, frame or structure, rigid frame or structure, locked chain and forms the such a type of chain is called as locked chain, or it is also generally used in the bridges and trusses of this type of structure only. Okay. Next one is another link with four links we are observing. So this is the mechanism we are observing, plane mechanism. Four links AB, BC, CD, AD with the four links. So now number of links is 4, number of joints is 4 and number of pairs is also 4. So from this substituting the equations, left hand side value is equal to right hand side value, therefore it will become say kinematic chain. Similarly second equation also you can substitute J is equal to 3 by 2 L minus 2, J is 4, 3 by 2 into 4 minus 4, 2, it is 4, both are equal, therefore it is satisfied the two equations, therefore it is a kinematic chain of 1 degree of freedom. So why you are calling as 1 degree of freedom means, so it is one input parameter is sufficient to know the other positions links. Other link positions also can be definite. Okay, single link such as AD is insufficient to define the position of all other links, then it is called as a kinematic chain of 1 degree of freedom. Now a definite displacement is given to the link AD, then by keeping the link AB fixed, then the resulting displacement of the remaining two links BC and CD are also perfectly definite. This thus we see that in a 4-bar chain the relative motion is completely constrained. Okay, in 4-bar, this is a 4-bar chain because we are calling as four links are having, that's why it is 4-bar chain or quadric cycle chain. Okay, this is also called as quadric cycle chain or 4-bar chain, hence it may be called as a constrained kinematic chain, and it is then basis of all machines. So this is the basic thing for any mechanism. We are taking simple mechanism. Okay, 4-bar chain. Next one is 5 links. In this figure you are observing 5 links, 5 joints, and number of pairs also 5. So substituting this case, okay, L equal to 2p minus 4, substituting the values, so this is number of links is 5, but 2p minus 4 value is 6, that is left hand side value is less than right hand side value. So and same time another equation here substituting j equal to 3 by 2 L minus 2. So because these are all kinematic lower pairs, that's why you are substituting this equation. So 5 equal to 3 by 2 into 5 minus 2, so 5 is 5.5, this value got it, therefore left hand side value is less than the right hand side value. So therefore this type of arrangement is called as unconstrained chain. This is not constrained chain because the relative motion is not completely constrained. This type of chain is of the little practical importance generally. So constrained chains only importance in the machines, so that's why we are talking about mainly kinematic chains, means constrained chain only. Next one is consider an arrangement of 6 links by adding the 2 more links to the previous 2. So now that is EF and FG or the 2 links are added for this one. Okay, now number of links will be the 6, number of pairs will be the 5, number of joints will be the 7. Okay, now L is 2p minus 4, substituting this equation both are equal, left hand side value is same as the right hand side value. Similarly j is equal to 3 by 2 L minus 2, this value substituting the values in this, so left hand side values is equal to right hand side value. So therefore it is also satisfied the two equations, therefore it is a kinematic chain, it is constrained motion. Then chain more than 4 links is known as compound kinematic chain. Previous case only 4 links are there, that is called as simple mechanism or simple chain. Now it is called as compound kinematic chain. Next video we are going to discuss remaining things, so that is plane movability and other things will be discussed next video. Thank you.